There's a star in the sky that could explode at any moment, and when it does, you'll see it with your own eyes. Even during the day. Its name is Betelgeuse, a red supergiant on the verge of dying in one of the most powerful explosions in the universe. A supernova. If it were in the place of our sun, it would swallow every planet up to Jupiter. And in recent years, something strange started happening. Betelgeuse dimmed. Its brightness dropped so drastically that astronomers around the world thought it was about to explode right then. But it didn't. It lit up again. And now, the mystery has only grown. What's really happening to this star? Are we about to witness a historic cosmic event? Or are we being misled by something we don't fully understand yet? The truth is, Betelgeuse is dying. And the real question isn't if, it's when. Betelgeuse is one of the most recognizable stars in the night sky. But what few people know is that it's also one of the most dangerous. Located in the constellation Orion, it sits at the hunter's right shoulder, glowing with an unstable, orange-red color that sets it apart from almost every other star around us. But that glow isn't steady. Betelgeuse is dying, and when it dies, the universe will shake. This star is classified as a red supergiant. That means it has already burned through most of its life and is now in the final stages of nuclear fusion. Unlike our sun, a yellow dwarf with a lifespan of about 10 billion years, Betelgeuse lives fast and dies young. It's only around 8 to 10 million years old, which in cosmic terms is barely a blink, and it's already close to collapse. Its size is beyond enormous. If we place Betelgeuse where our sun is, its surface would reach past Jupiter's orbit. That means Mercury, Venus, Earth, Mars, even the asteroid belt, would be swallowed without resistance. Its diameter is estimated to be over 1,400 times that of the sun, and its volume could be more than 1 billion times greater. That's almost impossible to visualize. A star so big that if you traveled around its surface at the speed of light, it would take hours to complete a single lap. But for all its size, Betelgeuse isn't dense. It's bloated, diffuse, like a giant balloon ready to burst. Most of its outer layers are barely held together and constantly being blown away. Observations from the Hubble Space Telescope and ALMA have shown massive jets of plasma and enormous clouds of gas and dust erupting from it, stretching across billions of kilometers. These are the final spasms of a star that can no longer sustain itself. At the end of 2019, something unexpected happened. Betelgeuse dimmed dramatically. Within a few weeks, its brightness dropped by about 40%. It was the biggest dimming ever recorded for this star. Astronomers immediately turned their telescopes toward it. The question on everyone's mind was the same. Is this it? Months later, the mystery was partially solved. The dimming wasn't the beginning of a supernova, at least not yet. It was likely caused by a massive cloud of dust, expelled by Betelgeuse itself, that blocked part of its light from reaching us. But even if it wasn't the end, it was a clear warning. This star is unstable, and the countdown has already begun. So, what's causing that instability? It all starts in the star's core. Stars survive by fusing lighter elements into heavier ones, hydrogen into helium, helium into carbon, and so on. Each stage releases energy that keeps the star from collapsing under its own weight. But this process has a limit. When a massive star starts producing iron, everything stops. Iron doesn't release energy when it fuses. It consumes it. It's a dead end. Once the core is filled with iron, the balance breaks. Gravity wins. In a matter of seconds, the star collapses. Then, in one of the most violent events in the universe, it explodes. A supernova. A burst of light and energy so massive that for a short time, Betelgeuse could outshine an entire galaxy. That's right, one single star, shining brighter than billions of others combined. And here's the most unsettling part. It may have already happened. Betelgeuse is about 640 light-years away from Earth. That means the light we see today left the star over 6 centuries ago. If it exploded back in the 1300s, we wouldn't know until the light finally reaches us. At any moment we might look up and see a new star in the sky, a brilliant point of light, so bright it could be visible even during the day. Luckily, Betelgeuse is too far away to harm us directly. The radiation from its supernova won't be strong enough to damage Earth. But make no mistake, it would be one of the most extraordinary events in human history. Astronomers have been waiting for this for generations. It would be the closest visible supernova in over 400 years, since Kepler's supernova in 1604. With each new observation, Betelgeuse shows more signs of nearing the end. Its surface is lumpy and uneven. It pulses irregularly, it's breathing, like a star in distress. And yet, even with all the data we have, we still can't predict exactly when it will explode. But one thing is certain. It will explode. It might be tomorrow, it might be in 100,000 years. But Betelgeuse is on a timer, and that clock is ticking. When it finally goes supernova, the world will stop to watch. Not in fear, but in awe. Because even in death, Betelgeuse will shine one last time. A final blaze that cuts through time and space, reminding us that the universe is alive, and that even giants must fall. Betelgeuse is one of the most closely monitored stars in the sky. Every major observatory on Earth, from Chile's Atacama Desert to the peaks of Hawaii, keeps a constant eye on its behavior. It's become the subject of dozens of scientific papers, thousands of simulations, and more hours of observation than almost any other star beyond our sun. And yet, we still don't know when it will die. Why is that? The truth is, watching a supergiant die isn't like observing a clock. The clues are hidden beneath the surface, in layers of gas, plasma, and radiation we can't fully penetrate. Even the most advanced instruments we have can only scratch the surface of what's happening deep inside. Telescopes like the Hubble Space Telescope, the Very Large Telescope in Chile, and ALMA, the Atacama Large Millimeter by Sub-Millimeter Array, have given us unprecedented views of Betelgeuse. They've shown us its violent convulsions, massive plumes of gas, and irregular patterns of brightness. But even with these powerful tools, we're mostly observing symptoms, not the root. 'Cause we know the star is unstable. We know it's shedding material, but whether that means it will explode next week or in 50,000 years, that's still a mystery. The main challenge is that we've never actually witnessed a supernova from this close before, not with modern technology. Every nearby supernova in recorded history happened long before we had the tools to study it in real time. What we know comes from distant explosions in other galaxies, bright flashes that give us light curves and chemical traces, but no internal anatomy. With Betelgeuse, we're trying to do something completely new, predict the moment of death before it happens. It's the ultimate cosmic autopsy, except the patient is still alive. To make sense of what we see, astronomers run thousands of simulations. These models try to replicate how red supergiants evolve, pulsate, lose mass, and eventually explode. They rely on equations of nuclear physics, fluid dynamics, magnetic fields, and radiation transport. It's one of the most complex problems in modern astrophysics, and Betelgeuse is the perfect test case. Some models suggest that we're in the final decades of the star's life. Others say we might be centuries away from the collapse. The problem is, the outcome depends on variables we still can't measure precisely, like the exact mass of Betelgeuse's core, or how fast it's rotating on the inside. These aren't details we can just look up. They require inference, indirect measurements, and a lot of guesswork. There's also another complication. Betelgeuse is changing rapidly. Its shape isn't perfectly round. It pulses, twists, and bulges. It's not a quiet dying star. It's a chaotic one, and every new convulsion adds more uncertainty to our predictions. In 2020, after the infamous dimming event, astronomers noticed that Betelgeuse wasn't just recovering. It was behaving differently. Its pulsation periods had shifted. The star's shape seemed to warp. It was as if something inside had changed. Some internal layer had moved, or some fusion process had stalled. And again, we couldn't see it directly. Even now, some scientists believe Betelgeuse might be hiding something more dramatic, like a hidden companion star or an unusually fast-spinning core. These ideas remain unconfirmed, but they're part of the growing realization that Betelgeuse is more complex than we imagined. Meanwhile, the public waits. Every time the star flickers or dims slightly, headlines appear. Is Betelgeuse about to explode? And astronomers sigh. The truth is, probably not. But one day they'll be right, and when that day comes, the world's observatories will be ready. Dozens of space telescopes, radio dishes, neutrino detectors, and gravitational wave observatories are standing by, prepared to capture the supernova from every possible angle. It will be the most studied explosion in human history, and Betelgeuse will become, in death, the most important teacher the cosmos has ever given us. When Betelgeuse finally dies, it won't go quietly. In the final seconds of its life, the core of the star will collapse under its own gravity, in a violent implosion that happens faster than a heartbeat. In less than a second, the core will shrink into a neutron star or maybe even a black hole, while a massive shockwave races outward, tearing through the outer layers of the star at thousands of kilometers per second. And then, the explosion, a supernova, brighter than a billion. Suns will erupt in Orion's shoulder. From Earth it will be visible even in daylight. For weeks, possibly months, we'll see a new object in the sky. A second sun that rises at dusk and fades only with the dawn. Not blinding, not dangerous, but unmistakable. A brilliant, steady glow in the night sky. For many people, it will be the brightest thing they've ever seen outside the sun and moon. In places without light pollution, it will cast shadows at night. It may even be visible during the day, just like Venus sometimes is, only brighter, sharper, and far more mysterious. And it won't be a brief flash. This isn't a shooting star. A Type 2 supernova like Betelgeuse's can stay bright for weeks or even months. Slowly, it will fade, turning redder and dimmer over time. But for a while, millions of people will look up and ask, "What is that?" The answer: the death of a star 600 light-years away. An explosion that happened centuries ago but only just now reached us. But there's more. When the supernova occurs, it will release not just visible light, but a flood of other signals. High energy, neutrinos, X-rays, gamma rays, and gravitational waves. Observatories across the world will go into alert mode. For the first time in history, we'll capture a complete multi-messenger profile of a nearby star's death. And Betelgeuse isn't just any star. It's iconic. It sits on Orion's shoulder, one of the most recognizable constellations in the sky. Children learn to spot it. Cultures have named it. Myths have been written around it. When it goes, even casual sky watchers will notice something's missing. Orion will look wounded, incomplete, like a memory with a piece missing, but this isn't the end of the story. Far from it. After the explosion, a nebula will begin to expand around the former star's position. Over decades, and then centuries, it will grow into a glowing cloud of gas and dust, much like the Crab Nebula, which came from a supernova recorded in 1054 AD. Future generations will see a new structure in the sky, the tombstone of a giant. And if Betelgeuse leaves behind a neutron star, astronomers may eventually detect it, spinning rapidly and emitting pulses of radiation, like a cosmic lighthouse hidden inside the wreckage. A new chapter in the story of this star. The death of Betelgeuse won't harm Earth. We're far enough to be safe. But it will change the sky forever. It will change astronomy. It will change us. When a massive star like Betelgeuse explodes, it doesn't just vanish, it transforms. The supernova will eject vast amounts of material into space, gas, dust, and heavy elements like carbon, oxygen, iron, and even gold. All of these are forged in the star's core or during the explosion itself, through a process called nucleosynthesis. These elements are crucial. Without them, planets like Earth couldn't exist. They're the raw materials of rocky worlds, atmospheres, and even life. As the supernova remnant expands, it pushes this material into the surrounding interstellar medium. Over time, thousands to millions of years, this debris mixes with nearby gas clouds. Eventually, gravity starts pulling the gas and dust back together. And in dense regions of these molecular clouds, new stars begin to form. Sometimes entire stellar nurseries are born out of the remnants of a supernova. Inside those nurseries, planets will eventually take shape around newly forming stars. So in a distant future, it's possible that parts of Betelgeuse, atoms once fused in its core, will become part of new solar systems. maybe even new, habitable worlds. This is how the galaxy recycles itself. And the process is not hypothetical. We've seen it. Telescopes have observed star-forming regions like the Eagle Nebula and the Orion Nebula, where evidence of past supernova is mixed with newborn stars. Even our own solar system may have formed in a region enriched by a nearby supernova. Traces of certain isotopes in meteorites suggest that a stellar explosion occurred just before or during the birth of our sun. In that sense, Betelgeuse is following a path we know well: die, release its elements, enrich space, and help shape the next generation of stars and planets. It's not just an ending, it's a reset button for the cosmos. Betelgeuse is about to shine like never before, and its death will be a unique spectacle in the sky. What do you think about it? Leave your comment below. If you enjoyed the video, like, share, and subscribe so you don't miss the next cosmic explorations. See you next time.